Every connected product eventually reaches the same question. Can you prove that it works, not once, but repeatedly, traceably, and under control? Modern validation is fragmented across requirements, devices, permissions, methods, instruments, spreadsheets, screenshots, and reports. The work may be happening, but the engineering chain is difficult to review and even harder to reproduce. Rigmettle brings that chain into one governed validation workspace. It does not begin by running a test. It begins by establishing what is authoritative, what is known, what remains unknown, and who is allowed to decide. Mission control opens passively. No device discovery, execution, or evidence creation begins on its own. The active source is visible before any result, so simulation cannot be mistaken for a physical connection. The operator chooses when to enter the sanitized demonstration, and the interface preserves that classification across every workspace. This is the first control, authority before activity. Rigmettle makes the state of the environment explicit, keeps unavailable evidence unavailable, and gives the engineer a clear next action without promoting an assumption into a fact. Rigmettle begins before the test starts. It establishes what the device under test is, what source supplied each fact, and what the platform still needs to prove. This demonstration uses privacy-reduced, deterministic identities. A friendly label is never treated as physical identity, and a connection handle is never promoted into a device claim. Simulated, recorded, imported, physical, and unavailable sources remain distinct. That separation matters because evidence can be internally consistent without proving who created it, which device produced it, or whether a different physical unit would behave the same way. Capability is not a single yes or no. Rigmettle distinguishes supported, partially supported, blocked, unsupported, and unknown. During this isolated demonstration, physical mapping is paused, and the capability view defaults to recorded evidence. A capability may be declared, but not observed. It may be technically available, but blocked by permission, access, equipment, or authorization. Unsupported remains different from unknown. These states prevent the platform from turning missing information into confidence. The result is a truthful inventory of what can be considered now, what needs evidence, and what cannot proceed. When instrumentation is connected, Rigmettle streams measurements into synchronized engineering views, so trends, transients, and anomalies can be evaluated as the test runs. A test without a requirement is activity. A result without evidence is an opinion. Rigmettle controls the source document, revision, original statement, verification need, ownership, and acceptance authority state for every requirement. These sanitized examples deliberately include incomplete inputs. The platform does not invent an acceptance limit to make the workflow look finished. Missing authority stays missing. Unreviewed requirements stay unreviewed, and revision history remains visible. The engineer can see exactly which controlled statement is driving the work, and which decision still requires an authorized source. Rigmettle connects the entire validation chain: requirement, controlled method, readiness, approval, execution, evidence, and status. Here, the requirement and method are linked, but linkage is not compliance. Readiness is blocked, so approval remains required. Execution is not run. Evidence is pending, and the final status stays blocked. The gap is not hidden by a green summary. Every transition retains its exact source revision and relationship. Reviewers can move from a claim back to the method, from the method to its prerequisites, and from any result to the evidence that supports it. Before execution, Rigmettle evaluates readiness as a deterministic gate. Device identity, software and firmware, interface access, method revision, instruments, calibration and equipment health, acceptance limits, evidence storage, safety, and operator approval all remain visible. In this example, the digital multimeter is unavailable, its health is unknown, evidence storage is unavailable, and controlled authorizations are missing. The method is blocked. That is not a test failure. It is the platform refusing to create a result when the conditions for a defensible result do not exist. The governed test library contains 50 draft methods across device, sensor, connectivity, reliability, data, software, evidence, and power families. A documented method is not automatically an implemented runner. Rigmettle separates lifecycle state, applicability, execution support, prerequisites, and disposition. A method can be relevant and still be blocked because equipment, calibration, access, limits, or authorization are missing. Physical mapping remains visibly paused in this demonstration. The library becomes a controlled engineering catalog, not a menu of buttons that imply the platform can perform work it has not implemented or been authorized to run. VaVa is the controlled intelligence layer. It does not replace the engineer. It gives the engineer an explainable view of what is known, what is unknown, which methods appear applicable, which are blocked, and why. VaVa distinguishes observed facts, declared facts, recorded evidence, simulation, recommendations, unknowns, and operator decisions. It identifies missing equipment, access, calibration, documentation, acceptance limits, and authorization. It recommends a dependency-aware sequence and the evidence each step should produce. It never invents a test, limit, measurement, identity, capability, physical validation, causation, or verified status. VaVa recommends. The operator decides. A recommendation becomes work only through an explicit operator boundary. Rigmettle binds the selected method and procedure revisions to an approved plan, preserves dependencies and requirement links, and distinguishes executable, guided, observation only, replay only, planned, and blocked support. The operator acknowledges prerequisites and starts the bounded local runner. Every step records its status, observations, evidence references, pauses, skips, and deviations. Technical completion is separate from pass or fail when acceptance authority is not identified. The assistant recommends, the operator approves, the platform preserves the evidence. Execution produces a traceable evidence package with provenance, stable relationships, a deterministic manifest, and 10 independently verified entry digests. Rigmettle can export the package, reopen it, reproduce the record, and verify that the content still agrees with its manifest. Authenticity remains unverified, and the physical status remains unchanged. Digest agreement does not prove authorship, custody, calibration, or device identity. A contained modification is rejected safely and reported here, where it supports the evidence story, rather than following the operator into unrelated chapters. Integrity is explicit. Its boundary is equally explicit. One run tells you what happened. Controlled investigation, baselines, revisions, trends, and multi-unit analysis show you what is changing. Rigmettle structures observation, hypothesis, experiment, evidence, and conclusion without promoting correlation into causation. Qualified source revisions stay attached to baseline comparisons. Trend flags remain separate from pass and fail. Exact cohorts expose missing data and outlier flags across privacy-safe units. VaVa can recommend a controlled follow-up, but authorization stays with the operator. The evidence chain becomes reusable engineering knowledge, while physical fleet testing and root cause remain unclaimed unless they are actually established. Rigmettle brings governed requirements, controlled methods, deterministic VaVa recommendations, operator authority, bounded execution, traceable evidence, and engineering learning into one provider-neutral foundation. Secondary workspaces preserve detailed telemetry, session lifecycle, protocol validation, contained faults, device comparison, and passive metadata without displacing the core validation story. The platform shows what works, what is blocked, and which physical gates still require authorized acceptance. It does not turn unknowns into claims. It turns controlled engineering work into a chain that can be reviewed, reopened, and reproduced. Every result should answer 3 questions. What did we know? Who decided to proceed? And what evidence proves what happened? Rigmettle keeps those answers connected. Engineering validation you can prove. Rigmettle. Request a technical demonstration or begin technical discovery at rigmettle.com.